In our spreadsheet, there's 4 tabs. First tab is distributions. You can put the lambda and mu in there. Lambdas, of course, are arrival rate. Mu is our service rate. And get the look of the distribution if you'd like to do that. Model 1 in the spreadsheet corresponds to example 7.1. And so this is real straightforward. You put the arrival rate, you put the service rate in there, and it calculates everything for you. Same thing for example 2. Again, we have constant service times here. You just put the numbers in there, it does the calculations for you. You'll notice it doesn't calculate any probabilities because there aren't any. And then there's model 3, which corresponds to example 7.3 in your text. And up here, you put the arrival rate and the service rate, as you might, and the number of servers or channels, okay? And in this gray box are calculations. Now, it will calculate what we call the average utilization here. However, and that's a standard lambda over mu kind of thing. We'll look at that in more detail. Well, we won't. But we'll look at utilization in a minute. This number in salmon we have to look up in exhibit 7.12. And the basic thing there is you take this average utilization number, that's lambda over mu, go down the column at the very left, find the 3.75 and go across and pick out the number of servers that you might choose. And you say, well, the number 3.75 isn't in there. You have 2 choices. One is you can approximate the whole mess by just call it 3.8, perhaps. You could do that. I don't recommend that particularly, and in fact, I think it's sufficiently inaccurate. We get the wrong answer out sometimes, and so there's a thing here at the bottom that does what we call interpolates, and in the lambda over mu, L over M column here, what we would do is, since 3.75 is between 3.6 and 3.8, now those are the 2 numbers that are in the table, we put 3.6 here, and we put 3.8 there. Excuse me, let me put 0.8. Okay, I put that in there. And I want over here, right under the difference of LM, I want 3.75 in there. Okay. Now, it still hasn't calculated anything because I have to look up the numbers. So let's for example, for 7 servers up here on top, I go down the L over Q column, the lambda over mu column, and I find 3.6. I go across till I find the number of service channels for 7, and that number is equal to 0.0912. I put that number in there, and the other numbers don't make sense yet. We have minuses, which isn't, and I need to find that same number, 7 servers for 3.8, and that number is 0.1292. And I hit enter, and it calculates everything. And the number that I need is here at the bottom, the 11.97, and I have to go up and put that in here, 11.97. Oops. Sorry, 0.1197. There we go. Enter that, and then I can see that the numbers have been updated. A student asked a question, what the average time a customer spends in the system is 0.06, and it's 0.0645 hours. If you want to read that in minutes, so it's easier for you, you just type equals, and then you point at that number, that 0.0645 times 60 to turn hours into minutes, and you see that it's 0.38697. So that's good. Now, the other thing you want to do is calculate utilization here, and a reasonable calculation of that is to take the total amount of service that's offered, divide it by the arrival rate, and that'll give you the number. So It's lambda over mu as is normal. Here the mu is 16, but we have 7 service channels, so we multiply the 7 times 16. So I'll do that right here. This is equal to lambda 60 divided by, open parentheses, mu times the number of servers, and hit enter. And you see in this case, our utilization rate is 0.535. So that should help with use of the spreadsheet. If you can do all that stuff, you can complete the assignment.